Hi guys, today we are going to look into ideal gas law. So this is my first YouTube video and I will be talking about this concept called ideal gas law. I have prepared some short notes which will be helping me to take or present this video. Okay, so I will first straight away present what is this equation and then clearly tell you what I am going to talk about in this small video. So the equation that I am going to talk about is PV is equal to nRT. Okay, so P into V is equal to N into R into T. So P is pressure, V is volume, N is the number of moles, R is called the gas constant and T is the temperature. Alright. So what I am going to present in this video is not only about this particular equation but generally about how equations in physics works, how we have to understand a particular equation in physics. Okay, because there are a lot of equations in physics and generally people think in physics, since a lot of equations are coming, it is very difficult to understand. It's not like that. It is actually very simple to understand when you know what that equation is trying to say. Okay, so now why are equations present in physics? Physics is how the world works. Equation is a mathematical thing. Why should equations be present in physics? That is the most important questions for which we have to understand the answer. Creation is made in such a way that most of the things that is happening in the real world have some kind of mathematical pattern into that. See, now when you blow balloon into an air, how big the balloon becomes depends upon how much air you blow into that. So here we have a simple mathematical concept present. What is that mathematical concept? More the amount of air blown into the balloon, bigger the volume of the balloon. Am I right? We will be looking into that using this equation PV is equal to nRT. So this is how every equation in physics have to be handled. Like what is going to vary when a particular another thing is changed or varied. This is the most important thing that I will be addressing today. What is that? How we have to understand equations in physics. So let's get into this equation. PV is equal to nRT. This title says 3 beardless scientists and pressure cooker. Okay, so I will be talking about pressure cooker for most part of this video, using the pressure cooker and the balloon to explain how this equation works and what has 3 beardless French scientists got to do with this thing, this equation. Let me start with a simple thing. So this is a box. This box has a particular volume. So what is volume? Volume is nothing but the space occupied by this box. See, now this space is measured in meter cube or in centimeter cube. What is that? What is meant by volume? It is the space occupied by this particular box. Now this box is filled with air, or generally as we call, this box is empty, but it is not actually empty, it is filled with air. Now we can fill this box with water, we can fill this box with sand. Whatever we do, the space that this box occupies does not vary. The space occupied by this box does not vary from time to time. You understand? So the space occupied by a particular thing is called as volume. Okay, so now let's talk about pressure. What is pressure? I am going to explain it using a very simple concept. Let's use what everybody have on their very own bodies, the mouth. All right. So now when I fill my mouth with air, it is going to blow up and bulge. Am I right? See, what did I do? I just filled my mouth with air and because of that it bulged. Am I right? Yep. So why is it bulging? When you give more air into the mouth, then the quantity of air molecules coming into the mouth is increasing. So because of that, the mouth uh, becomes big in volume. Why? More the air molecules, more the volume that has to be given for those air molecules, right? You cannot put all the air molecules in a very limited space. As and when the air molecules are being increased in a particular space, the volume occupied by those air molecules also increase. So I am going to increase the volume of my mouth by filling it with air molecules that I am going to pump in from my body. So I am going to do this incrementally so that you can see how the volume of my mouth increases and my cheeks bulge accordingly. So what did I do? This is a very simple thing. I increased the quantity of air molecules in my mouth by taking the air from my throat and filling my mouth with it. So more the air molecules, more the volume occupied by those air molecules, hence correspondingly my mouth and my cheek bulged. Am I right? Yes. So that is the first thing. That there was this scientist called Avogadro. All right. So Avogadro said something very simple. More the substance, more the volume it requires. That is very simple, right? Now imagine this box is full of air. This, if you are going to pump in more and more air into this particular box, then the space of the box has to increase. What happens if it is not going to increase? This box will not be able to contain more number of air molecules and ultimately it is going to break. Am I right? Yes. So Avogadro said more the substance, more the volume required. Yep. Now there was this another scientist who was called Boyle. Alright. So Boyle's law states that when the volume increases, okay, when the volume increases, then definitely the pressure decreases. For that, what he said was that the amount of substance inside the box is assumed as constant. Imagine this is the volume and the gas inside is going to be sort of constant. What do I mean by constant? The quantity of gas present here is constant. But now imagine I am not going to let this air to escape out, but I am going to increase the size of this box magically. So when I increase the size of this box, what is going to happen? Imagine there are 100 gas molecules inside, and imagine that the volume of this particular box is 10 centimeter cube. Okay, I am just giving random values. So 10 centimeter cube and 100 gas molecules inside. Now this 100 gas molecules inside will exert a particular pressure on the wall, right? So what I am going to do is, when I increase the size of this particular box, then the pressure or the force applied by the air molecules inside the box is going to reduce. Why? Because those air molecules now have more space, that is more than 10 centimeter cube to move around. So the force that they are going to exert on the wall is going to become less. This is said by Boyle. This is called Boyle's law. There was this another beardless French scientist by the name Charles law. He proposed something that is called Charles law. So Charles law states that the volume is proportionate to temperature. That is a beautiful law. Imagine there are, like, say 100 gas molecules in this box. Let the volume of this box be 10 centimeter cube. Alright. So now when the temperature of this particular gas is increased, now I am giving heat energy from outside and this gas is increasing in its temperature. What happens when it increases in the temperature is that the gas molecules absorb this heat energy, and because of that they start moving very fast. inside this box. Now we cannot see the gas molecules, but what happens when heat energy is provided? This gas molecules start moving in a very fast manner inside the box, and because of that the space or the volume of this box will not be sufficient for this particular gas molecule, this particular number of gas molecules present inside the box. Imagine this. Imagine there are say 10 kids in a room. Now these 10 kids are sitting properly and they are very silent and they are just playing in a very soft manner. Then the space of that room will be sufficient for this 10 kids. Imagine now they all are in a very playful mood. They are just running randomly here and there. They are not sitting in a place. They are running randomly here and there with very high speed. What happens? They collide into each other, right? So when they collide into each other, they realize that this particular space is not enough for them. They need to go out into the ground, or they need to go into the playground or something, so that they have more space to run around. This is the thing. So whenever the temperature of a particular substance is increased, the molecules start moving in a very very fast way, and since the volume in which they are there is not sufficient for them to move around, the volume starts increasing. Alright, or in other words, the quantity or the substance present in the particular space move around, or they expand, requiring more volume. Alright, the volume, when I say the volume increases, it means that the substance inside expands and requires more space. Alright, the same amount of substance. It's not like 100 molecules has become 101 molecule. Not even a single molecule is added, but all the molecules are moving very fast, and because of that the space is not enough, the volume is not enough. So now we have seen three laws. Avogadro's law, okay, which says that the volume of a particular substance, the volume is proportionate to the quantity of substance, or in other words, if there are 100 gas molecules, then 10 centimeter cube is enough for them. If there are 200 gas molecules, then 10 centimeter cube might not be enough. We might be requiring 20 centimeter cube. Alright, so more the substance, more the volume occupied. So this has been proposed by Avogadro. And then comes Boyle. What did Boyle say? When the volume is increased, then the pressure reduces. This is what Boyle said. Or in other words, when the volume is decreased, the pressure increases. Volume and pressure are inversely proportional. Let me explain this. The same 10 centimeter cube volume is there. This box has 10 centimeter cube volume. I'm just saying this value. This box, I'm not sure whether this box is actually 10 centimeter cube. It will be more or less something like that. But this box has a volume of let's just assume this box has a volume of 10 centimeter cube. Now there are gas molecules inside this. Imagine there are 100 gas molecules inside this. Now if I am going to increase the size of this box magically to 20 centimeter cube, then the pressure will reduce. Why? Now in 20 centimeter cube there are just 100 gas molecules, but initially in 10 centimeter cube there were 100 gas molecules. What is pressure? We need to understand what is pressure. Pressure is nothing but how much force is exerted by a gas molecule on the walls. See, again I can use my mouth, or we can use a balloon. But most of us, grown up kids will not be having balloons in their house. No problem, you can just use your mouth. Try to fill your mouth with more and more and more gas. Let's see what happens. Try and do it to the maximum extent. I'm going to do that now. What happened? I'm not able to put more and more and more air inside my mouth. At one point of time, I have to release that air through my mouth. What happens is that when I am increasing the number of gas molecules, then the volume increases. But after a particular point, the volume is not increasing. So the pressure builds up. pressure is nothing but the force that the gas molecules exert on the wall of a container. In this particular demonstration, the wall being my mouth and my cheeks. You understand? So when I am having such a, imagine I am just fully pumping my mouth to the maximum volume, but I am trying to suck in all the air. So what happens? The pressure reduces, or the force applied by the gas molecules inside my mouth is very less. So actually you cannot see my cheeks bulging out. Why? Because the pressure is less. I am going to do that now. See, it is very difficult. You need to try to keep your mouth full like this, but try to suck in the air. You cannot do that, because when you do that, you will not be able to keep your mouth bulged in. It becomes, it is just naturally, pulled inside. Why is this happening? You are reducing the pressure by, taking out the gas molecules inside your mouth. Therefore, the pressure is reduced. Alright? Therefore, the pressure is reduced. When the pressure is reduced, then obviously, the volume also gets reduced. Alright? So this is the thing. So how we have to understand this? This inverse proportionality is a little bit tricky. When the volume is actually, increased, if the number of gas molecules inside it is constant, then the pressure decreases. Why? When the space has increased, there are less number of gas molecules, and the less number of gas molecules will not be giving so much pressure against the wall. You understand? Okay. So this is the thing that you have to understand with respect to Boyle's law. So now I have covered Boyle's law, Charles' law and Avogadro's law. Now let's get into the beauty of this. Now the equation that we initially saw was P into V is equal to N into R into T. Alright? Yep. So the product of pressure and volume is equal to the product of the number of substance, or rather than to say the number of substance, the amount of substance which is measured in the number of molecules and its product with the temperature multiplied by R is this equation. What is R? R is gas constant. We will not be going too much into what is the gas constant in this equation, but we will just be looking into how this equation works and how this equation explains a lot of things which is happening in the physical real world. Alright? So I have just stated this equation. Now let me explain how this equation beautifully works and explains how things work physically with two examples. So I am going to use the example of balloon and pressure cooker. Yep. So let's talk about balloon. I think it is pretty much the same as how I explained things with my mouth. So let's stick to balloon, because it is a separate entity and it will be very convenient for us to use and appreciate how this particular concept works, this particular equation works. What happens in a balloon? In a balloon, when the balloon is not having any air inside it, or when no air has been blown into it, it is just in a very soft state, and it is small. Am I right? It has not expanded, it is small. Now I keep it on my mouth and then I blow in the air. What happens? The quantity of the air molecules is increased inside the balloon. The quantity of air molecule is increased inside the balloon. So more and more air molecules get inside the balloon, and when more and more air molecules get inside the balloon, then the volume occupied by those air molecules is also correspondingly more, right? It's very simple concept. Maybe 10 people can sit inside a room, but for say 100 people the same room will not be sufficient. It is a very, very obvious concept, right? So in PV is equal to nRT, when N is being increased on the RHS, that is the right hand side of the equation, when n is being increased, then on the LHS, definitely one quantity has to increase. What is the quantity which is increasing now? The volume. See, more the air molecules inside the balloon, more the volume, because only then LHS and RHS will be equal. Am I right? Now let's take a very simple, numerical equation. Something like 5 into 10 is equal to 2 into 5 into 5. Am I right? Yep. Now imagine I am going to do something very simple. On the LHS there are two numbers. What are those numbers? 5 and 10. On the RHS there are three numbers. They are 2, 5 and another 5. Now on the RHS I am going to increase that particular, one particular number by a magnitude of, say, just 1. Like, what do I mean? I am going to make this 2 as 3. 3 into 5 into 5. Okay, so now on the LHS, can I write 5 into 10? I just increased one of the numbers by just 1, right? I just increased by just 1. The first number was 2, I just increased it by 1. I made it 3. For that, this equation is no longer an equation, but it becomes an inequality. Why? The LHS and RHS are not equal. So, what happens when I am increasing this quantity here? When I am increasing one of the quantities in the RHS, then there should also be a corresponding increase in the RHS. So, if it is going to be 10 equal to 5 into 10 equal to 2 into 5 into 5, then if I am going to make this 3 into 5 into 5, then what is 3 into 5 into 5? 5 into 5 is 25, 25 into 3 is 75. Am I right? Yep. And so if it is 10 here on this side, then it has to be 7.5. Right? See, now something very simple has happened. When a particular quantity on the RHS has been increased, then definitely on the LHS there has to be a corresponding increase. Only then both the sides of the equation will be equal. Similarly, in this particular PV is equal to nRT, when you are increasing the number of gas molecules by blowing them into a balloon, on the LHS a value certainly has to rise. So now the pressure is not rising here, but the volume is increasing. Alright, how do we know that the pressure is not increasing? Because the balloon is in a particular shape only because the pressure in the atmosphere and the pressure inside the balloon are both the same. I will repeat again, the air pressure outside the balloon and the pressure inside the balloon are same. Only because of that the balloon is able to stay in shape. Imagine if the air pressure outside the balloon is more, what happens? The air pressure will come and it will crush the balloon. Am I right? Yes. So now when the air molecule is blown inside the balloon, the pressure also increases. But why? There are more gas molecules getting inside a very small volume. The more and more gas molecules are coming in, so the pressure exerted by these gas molecules on the walls of the balloon is increasing. But something beautiful is happening here. You know what? The balloon has the capacity to expand. Now this box doesn't have the capacity to do that. Imagine I am making a small hole here and making it airtight and pumping a lot of air into it. You know what happens? This box cannot increase in volume. So more and more gas molecules are getting into this box, and those gas molecules are pressurizing the walls of the box. So the pressure will increase, but the volume will not increase. But the balloon is a beautiful thing. You see, the walls are elastic. So when more and more air molecules get in, the pressure increases momentarily, but that pressure is compensated or it is reduced because the volume increases. You see how the increase in volume is reducing the pressure. When the pressure increases, when air molecules get inside a balloon, the pressure increases. But this increase in pressure is being reduced because of the increase in volume. You know what is happening? Hey, there are more gas molecules here. So you gas molecules are exerting more pressure on the wall. Don't worry, I will expand myself and give you guys more volume. So since more space is given by the balloon as it gets bigger, the pressure is being reduced. It is being reduced to such a manner it is equivalent to the pressure as outside the walls of the balloon, that is the air pressure. You know what, the balloon also can expand only to a certain level. So more and more and more gas molecules are put inside, the volume keeps on increasing, but the pressure is more or less the same as it is in the atmosphere. At one point of time the balloon cannot expand more, so the pressure starts building up, because after a particular volume the balloon cannot increase in its volume, so the pressure starts building up, and at one particular time the force exerted by the gas molecules on the walls is very high, because of which it is blasting. Now let's actually get to the interesting point where I want to talk about. Let's talk about the pressure cooker. Now you know what, every substance has this this, what to say, quality of expanding or increasing in the size and occupying more volume when you give more temperature. And the reason behind it is pretty simple. When you given more temperature, when you raise the temperature by giving it more heat energy, the gas molecules actually absorb this heat energy and start moving around. And because of this movement, what happens, the volume is not sufficient. I think I'm sure I already explained this. Okay, so more and more movement is happening with the same quantity of the gas molecules, because of which more volume is required. If you are not going to give more volume, then the pressure will only increase, because these gas molecules will move in a very fast way and with a great deal of energy, and this energy will be exerted on the walls of the container. It may be any container, it may be a balloon or anything. So we will see how the pressure cooker works in the last final part of this video. Okay. So we will be discussing in a very short duration of time how this equation is beautifully explaining how a pressure cooker works. See, now PV is equal to nRT. Let's take this pressure cooker. In the pressure cooker, what happens? Water and rice or anything that has to be cooked is put into the pressure cooker along with a certain quantity of water, and the cooker is tightly closed, that is, it is airtight. So now observe this carefully. The quantity or the substance measurement, or how much substance is present inside the pressure cooker after it has been closed, is constant. Why? The rice and the water is not going to increase. Alright, the rice and the water quantity is going to remain constant inside the pressure cooker. That is point number 1. Now there are just only 4 things that we are going to talk about here: the pressure, the volume, the quantity which is the N, the quantity of substance which is N, and the temperature. Okay, so the quantity of substance which is N, or which is measured in the number of moles or the number of molecules, it is not going to vary once you put that inside the pressure cooker and close it. Okay, yes. Now the volume of the pressure cooker is not going to change. Imagine it is like we have now 2-liter pressure cooker, 1-liter pressure cooker. Imagine it is a small pressure cooker, 1-liter pressure cooker, very small pressure cooker. So this 1-liter pressure cooker is not going to become 1.5-liter pressure cooker when we are cooking. So the volume is constant, right? And the number of moles or the total measurement or the quantity of substance that we have put inside is also constant. It is not going to increase or decrease. So here volume is constant, and the measurement of the substance is constant in the case of a pressure cooker. Now what is going to change on the RHS side? The temperature is going to change. So now we are going to give more and more and more energy, in heat energy, for this pressure cooker, because of the flames, and the temperature inside the pressure cooker is going to increase, and it will keep on increasing. It will keep on increasing. What did I say previously? In a particular equation, when any quantity in any one side of the equation is increased, there will be a corresponding increase in the other side of the equation. For example, the same equation that I told earlier, 5 into 10 is equal to 2 into 5 into 5. If I am going to make this 2 as 3, then definitely the LHS of the equation will not remain the same. It has to increase. So if I am keeping 10 constant, then 5 has to become 7.5. So if the temperature is being raised on the right hand side, something has to rise on the left hand side, right? So the volume cannot rise, because already we know that the volume of the pressure cooker is a constant. So what is going to rise? The pressure is going to rise. So when the heat energy is given in, the temperature increases. When the temperature increases, the substance inside the pressure cooker is going to move fast, in a very fast way inside this given volume. So the water is going to evaporate because of the heat energy, because when water is in liquid state, when you give heat energy, it absorbs that heat energy, it expands and becomes steam. And when you give more and more heat energy to this steam in which this water molecules are slowly moving here and there, starts moving in a very fast way here and there, and because of that the movement of this water molecules are very fast inside the container, and they travel with a great deal of energy, and they give very high pressure inside the pressure cooker. So that's the reason why this thing is called a pressure cooker. Why? Because pressure is increased, and because pressure is increased with the temperature, the cooking inside it happens. Alright? So now when the temperature is keeping on increasing, the volume remains constant, and the pressure cannot remain constant because the temperature is increasing though. So the pressure starts increasing, and when the pressure starts increasing to a great extent, then we put a weight on the top of the pressure cooker, right? At one particular time, the pressure will be so high that this weight moves up and releases a certain quantity of substance outside. Now what happens? This is a beautiful thing. You see, the pressure has increased to a great extent, and now the pressure can the pressure cooker is not able to contain the high level of pressure inside that. So something has to be done. So the weight actually moves up. Alright, the weight actually moves up, and when the weight actually moves up, the quantity or the substance inside the pressure cooker is released outside. So on the RHS, the quantity or the substance is reduced. Alright, because of this, definitely on the LHS, the pressure has to reduce. You understand? So again the same thing happens. Once the pressure is reduced with the available amount of quantity, more and more heat energy is added. Because more and more heat energy is added, again the pressure builds up, and once the pressure is not able to, once the pressure cooker is not able to contain the pressure, the weight moves upwards, and some more substance is released outside in form of steam. That's what you see when a pressure cooker gives whistle. You see the white smoke coming out, which is nothing but the quantity inside it is being released outside. Understand? This is how the pressure cooker works. Now let's consider how the pressure cooker blasts. You know what? Due to some technical fault, if the weight is very strongly fixed into the nozzle, the top nozzle, the temperature keeps on increasing and there is no way for the pressure to be released outside. So the pressure keeps on increasing. At one point of time, the pressure cooker is not able to tolerate that particular, that particular quantity of pressure, and because of that the entire lid is forcefully pushed outside with a blast, and all the rice or dal whatever you're cooking just comes out and it becomes all over the world, all over the ceiling. All right, so this is how this simple equation PV is equal to nRT can be understood with respect to what it does in the physical world. It is very simple. Each and every variable, what do I mean by variable? Each and every quantity, P, V, N and T are variables. Alright, so when a particular variable is increasing or decreasing, this is the equation. So according to the increase or decrease, there is going to be a change on the other quantities. So if temperature is going to increase, either pressure or volume should increase. If the number of moles are going to increase, then definitely there will be a rise in the pressure if the volume is constant. If the volume is not constant, then then the pressure has to increase or decrease. All right, so this is the thing. It is very simple. When one quantity increases or decreases on the LHS, then correspondingly there will be increase or decrease on the other side of the equation. Imagine I am taking a particular tight balloon, and the balloon has a given quantity of air molecules inside this. Inside it, and I am reducing its volume. I am making the volume very small. What happens? Because the volume reduces and the number of molecules inside the balloon is the same, this molecules will start exerting more pressure because it is the same number of molecules in smaller volume. So the pressure increases. I hope you understand how PV is equal to nRT works using this simple examples. Thank you so much for watching this video.